The hypothesis is 2x plus 5 is greater than 7, and the conclusion is x is greater than 1. Number 4, the hypothesis was if two lines form right angles, the conclusion was the lines are perpendicular. Number 6, if it is cheese, then it contains calcium. Little kids are great, but we don't need all that noise in our life right now.
If you buy cheese, then it will have calcium in that kind of.
Well, let's see. Let me read the original. Cheese contains calcium. There's nothing in there about buying anything. So I don't think that quite works. Make it simpler. Don't read extra information into the thing. That's a good idea for logic in general, and that's a good idea for talking about things in life. Don't read extra information that isn't there. 8, if a triangle is equilateral, then it is equiangular. Number 10 is a big fat hen. No, false. If x equals -4, then the -4 squared equals 16. So the hypothesis of the conditional is true, but the conclusion is false. It's proved false through counterexample, right? What?
4 squared, 16.
Yeah, but -4 squared is wait. Let me read these words. Let me go back to the beginning. Okay, so yes, 4 squared is 16, but x squared is not always 4, because it could also be -4. So if you can have a counterexample, then the statement is false. Just because it's true once doesn't mean it's a true statement. It has to be always true for it to be true. Number 12 is true. There's no counterexample possible. Number 14 is also true. Also can't have a counterexample to that one. That's funny. Number 14 is a funny problem. Okay. Number 16, converse is if a number is divisible by 2, then it is divisible by 4, and it's false. You could write a counterexample to disprove it. If we need to look at one specifically, you let me know. The inverse is if a number is not divisible by 4, then it is not divisible by 2. 2. Which is also false. Give you a counterexample. One possible one is 6 is not divisible by 4, but is divisible by 2. And the contrapositive is if a number is not divisible by 2, then it is not divisible by 4, which is true. 18, the hypothesis is two angles are adjacent, and the conclusion is they have a common side. Excuse me. Number 20, the hypothesis is 3x minus 4 equals 11, and the conclusion is x equals 5. What questions from that lesson? 16. Okay. So 16 says if a number is divisible by 4, then it is divisible by 2. So we want the converse, inverse, and contrapositive. So it might be easy. It might be easier to do that if we identify the hypothesis and conclusion. So what is the hypothesis of that statement? Okay, so the hypothesis is a number is divisible by 4. The conclusion is what? It is divisible. That's actually probably one way you could pronounce that word. I don't know. It is divisible by 2. Okay, so we're supposed to write the converse, inverse, and contrapositive, say whether it's true or false. If it's false, you need a counterexample to say that it's false. So what is the converse of a conditional statement? They're all three opposites. It's what kind of opposite? What do you change on the converse? You change the conclusion, what? What were you saying? Well, go look at your notes, y'all. What is the converse? What does the converse do? It what? It converses itself. Thanks. That's so sweet. Switches what? That is exactly true. It takes the hypothesis and the conclusion and it flips them around. Very Chrysler. So the converse of this would be if a number is divisible by 2, this is the conclusion, is divisible by 2, then it is divisible by 4. All right, so we just take the 2 and we switch the order, right? So now we got to determine whether this is true or false. It's false if we can find even one counterexample to the statement. So, yeah, 4 doesn't go into 6, so 6 is great. So it's false because 6 is divisible by 2, but not by 4. Some weirdness, right? How would we write that? 6, that'd be 3/2, 1.5 is 1.5, so not divisible. I don't know. Some words like that. Might be easier if we wrote it in English. Wrote 6 is divisible by 2, but not 4. That might be an easier way to explain what we're trying to say. Okay, so now we're supposed to write the inverse. What does the inverse do?
It's basically the same thing. It's just like, for example, if a number is divisible by 4, if the number is not divisible by 4, it's not divisible by 2.
Right. It negates them. Same order, but it negates both of them. So the inverse of this statement is if a number is not divisible by 4, then it is not, oh no, that's right, divisible by 2. Is that true or false? Okay, it's false. So we need to provide a counterexample that lets us prove that it's false.
Because 6 is divisible by 2, but 4 isn't.
So 6 is not divisible by 4, but is divisible by 2. Basically, any even number that's not divisible by 4 disproves this statement, right? So we could pick 10 if you wanted to, or a whole bunch of other options. Where is my eraser?
So I knew those papers.
Thank you. I knew that I moved it. I don't have enough room, so I'm going to write the contrapositive after erasing. So, what does the contrapositive do?
It flips it, but makes it twice true.
No. In this case, it is going to be true, but what does the contrapositive do? Look at your notes. Yes, the contrapositive.
Did we write that?
Huh?
Did we write that down?
I don't think we did.
You don't think we did in the notes?
Right, you did, right, what
Yeah, I had to write it myself afterwards.
Oh, it wasn't, the contrapositive was not in there? Well, then look in the book. Flip over to page 109. What does it do? It's turning one page if you were, like where you were supposed to be to begin with. What did the converse do? What did it do?
It flips,
Flip the order. What did the inverse do?
it flipped the order, but it
It negated it. No flipping, just negated it, right? Just leaves it in the same order. The contrapositive is the biggest ugly word, and it does the biggest ugliest amount of stuff. It does both. It flips the order and it makes it, and it negates it, right? So it changes the order and it makes it not. So in this case, in this statement, it would be if a number is not divisible by 2, then it is not divisible by 4. Is that true or false? Is there any number that is not divisible by 4 that is also not divisible by 2?
Yeah,
What?
odd numbers.
So that would be true on both. It would be true, true, yeah? So that works. That's not a counterexample. That's a good example, right? This is true. We're trying to look for something that makes it false. Is there anything that makes it false? No, you're right. It's true. It's a true statement. There's not a single counterexample in the real number system that proves this false. This is a true statement. So we don't need any counterexample. We just say it's true and we move on with our life. Make sense? So what y'all are telling me is I need to remake that video.
Yeah.
Yeah, that'll happen eventually. Just not today. Any other questions from this lesson? Any other things that are missing from your knowledge brains? Okay, let's look at the next lesson. We skipped a bunch of stuff. Went all the way to 2.7. But first, we need to real quickly, before we even do that, we need to point out that there is something that you need to, at your leisure, when it is possible for you to do, you need to copy all of the postulates from page 127 into your notes at some point. Basically, if you flip to page 127, tells you how many, the postulate says that 2 points make a line, yeah? And then 2.2 says 3 points make a plane. And then lines have at least 2 points. And planes have at least 3 points. If 2 points are on the same plane, then all the line is in the same plane. And then the important bits are that, well, it's all relatively important for building other stuff, but they're also postulates, so they're a little bit no-duh, right? So 2 lines intersect at a point, and 2 planes intersect at a line. Great, great. Let's look at what we actually did do today. What numbers did we do on 2.7? 2 through 12. Okay, we're going to need our television, I think, for looking at some of these proofs. You did 2 through 4. I don't know how you did that because number 2 should have taken at least 7 lines.
Number 2?
Yeah,
How?
because it's a proof. I don't think you understood what a proof was, which is fine, because this is the first lesson you ever did a proof, or ever tried to do a proof.
Oh.
Oh, did you read it wrong?
Oh.
What? Let me snap a picture, and then I'll come back and move the camera, and then we'll look at number 2. I imagine that we'll have some questions on the proofs. This is the first time you've ever done them, so I imagine that there will be a little bit of confusion, at least. I hope you engaged with it, but we'll talk about that as well. Check out your analytics. No, I'd rather not. I don't really care. As long as the people from my class that need to watch the video, I don't care. After that, oh no, not that one, this one. Okay. For the people who did attempt the proof, I'm going to give these to you. I imagine we'll have some questions on them, and we may do 1 or 2 in class and all the things. But there is number 2. The way they did it. Now, there's often, well, always, pretty much, more than one way to get there. Now, remember that in this textbook, like this, lines 2, 3, and 4, and well, all of them actually until the end, all of these, when it doesn't have a line over it, this means the measure of WX. So in your notes, if you did this line, it would say the measure of segment WX equals the measure of YZ. Yeah, so that's what those mean. Same for all these. These would all be measure of whatever, right? It is what it says in the book.
It says xy equals xy.
What are you saying?
That's what it says in the book.
It says segment WX is congruent to segment WZ
It says xy
on the given.
equals xy right here.
That, that is
Exactly what it says.
Well, see, here's the problem, kids. What lesson did you do? What lesson was the notes over? So I don't know why somebody didn't ask.
That's the wrong number.
I did. You're correct. I did put the wrong number. What lesson is 2-6 over? Excuse me. Page 139. What lesson does that go with?
That's 2-6.
That's 2-6. So time out. Hold up. So why we probably should have asked and said, did you mean, or something like that? Yeah, I know that it's my fault, and
Well, it does say algebraic proof.
it does. That's true. And I also said in no uncertain terms, if I ever assign anything to you that says it's an algebraic proof, that one is omitted. That was an accident. I didn't mean to assign you algebraic proof. I did say that out loud in class the other day. So all of this whole lesson would have been omitted, right? Based on those ideas and those thoughts, yes? So why don't we actually flip, and since everyone, or at least most everyone, did the wrong lesson, because I wrote the wrong lesson, admittedly, I'm not taking out my part of the problem. Let's go and do number 2 from the right page, page 147, together. And then maybe it'll make more sense. So now your statement makes even more sense. Now your statement is like, okay, this is nothing like anything he taught in the video. What is happening?
I was like,
Okay, well, there you go. So let's flip the camera around and let's actually just do number 2 together. Well, it's because we were probably going to do that anyway, because somebody was going to ask about the proofs, because that's just how it rolls, right? We almost certainly were going to do it anyway. So we'll just jump straight ahead to the punchline. All right. That works out just fine. We better turn the TV off so nobody tries to cheat. Oh, y'all are all looking real quick. There's no sense in sounding smarter than you are. Only be where you are, because if you cheat and you sound smarter than you are, then you've learned nothing. And then when it comes to the test, you'll be dumber than you ought to have been. So don't be dumber, be smarter. Here we go. Number 2 says, prove the following. So let me stick some stuff up on the screen. The screen. This thing right here. This is a whiteboard. What? Are you saying something dumb? Probably. I haven't picked on you once today. How does that make you feel? That's funny.
No, did she say it makes me feel sad that we guys have been
That is
No,
what.
I didn't say
That's what I heard.
I picked on you.
Yeah. Yeah.
Yeah, she's just sad she's not getting the attention she wants.
All right. So we've got this segment W, and then there's X, Y, Z, X, and Y, and Z.
Okay, you're a warrior cast kid. Literally asking to be bullied.
I am not.
Given
I will wings of
segment
fire.
WX
I won't bully a wings of
is
fire
congruent
kid. My cousin.
to segment YZ.
Like more than cats?
I'm a wings of fire kid, not a warrior.
You denounce that part of your heritage?
What?
You can't denounce your heritage.
I would go ahead and put it
Yes, I
for,
can.
because we're going to almost treat this like notes.
I can.
So no, you don't have to. Although oftentimes it's useful because then you can kind of write on it. On a simpler proof like this, but like when the shapes are crazier, I would write it just because it's going to be easier to brain it out, but you don't have to. Prove that WY is congruent to XZ. All right. We need our statements. Now I understand why you were asking all about algebra proofs the other day. So many things are starting to come together. I don't know why y'all would assume I would do something right. I didn't, you should always assume that I made a mistake and make sure and ask about it.
I was like, there's no way that number 2 will prove. What are you talking about?
All right.
So I just assumed, well, I must be ultra confused.
Y'all are like, he said that proofs were confusing and maybe he was just right.
Honestly, I don't know.
Is that kind of where you're
I was
at?
doing it like kind of late, so.
Right? It's like, well, it's too late to ask anyway. I'm just going to YOLO and hope for the best.
As in like 2 minutes before the deadline.
Okay.
I did make it.
What's the first line of a proof always going to be?
The
The given, right? So we're always going to have given as our first justification. WX is congruent to YZ. Oh, that
I
would,
feel like
I made a mistake. Thank you. Number 1, WX
you're just
is congruent to Y. Yeah, I was just making my point for myself. Good job. Good job, me. Okay. We're trying to get to there. What lesson is this in? 2.7. That's unit. 2.7. Right? What is the main theorem in 2.7? I already asked this earlier and you answered it, but answer it again. Now, segment addition. So what are we probably going to use in this proof? Segment addition. That should, like, those kind of ideas should be clues. Now, it's important to note that the further we get, the less that'll always be true, because down in here, we're going to use segment addition. Again, like, we're going to use segment addition all the time, like forever and always. Angle addition, forever and always. So we're never going to stop using it. We're just probably going to at some point use whatever the new thing was as well, or whatever else. And we're going to write complicated proofs that have all of these lines, and then you're going to be really thrilled when we get to triangles because you're going to write proofs that are 3 steps long, and it's going to be great. You're going to think, oh my gosh, I can actually do this finally. It's going to be great. All right, so we're trying to get to, so what I was telling Brody is useful words. So it's handy if you will mark what you're given and kind of mark up your picture as you go. That way you can kind of have a frame of reference for what you're doing and what's going on, right? So I'm going to mark my given. So Wx is this one right here. So Wx is congruent to Yz. So we are given this. I'm even going to mark this in red so we can remember what's going on. So that's all we know. And what we're trying to prove, I'm going to mark that as well. What we're trying to prove is Wy. So we're trying to prove that this is congruent to probably xz, yeah? Yeah, xz. Trying to prove that this is congruent to that. So we're trying to get these big bits. So this one is congruent to that one. But all we're told is these two things. Right? Makes sense? Now, so I asked about segment addition. What does segment addition say? What does it actually say? Yeah, no, like, what does it say, like, in symbols? Yeah, that's exactly what I'm looking for. That's enough to get us there. It is the measure of this plus the measure of that equals the measure of this big one. So it's all the measure of this equals the measure of that, right? We're given congruent. So congruent is not the same as measure, right? Congruent is for pictures, measure is for numbers. So before we can use this, it needs to say the measure of Wx equals the measure of Yz. Luckily for us, we have a way to get straight from there to that, to turn these from congruents to measures. What do we say? What can we say that does that?
We can say, we can use the property, what the definition of congruency.
Yeah. So we can turn, yes, I'm going to write what you said first. So the definition of congruent segments, so because of what they are, we can say the measure of Wx equals the measure of Yz. That's great. That's easy. We did a thing that was useful and it was easy. Now comes the hard part. Okay. Now is where you start scratching your head and being like, I don't know where to go. I give up. And you move on to the next problem. But let's see if we can figure out some ways to not do that. So you're not necessarily always going to know the fastest way to get to the proving the thing. There's more than one way to go through this proof. There's more than one path to get there. A lot of times that's what real mathematicians do. They'll make this big old huge complicated proof and whatever else, and then they'll figure out how to make it more straightforward and more streamlined and find shortcuts to do things, and they'll take all this stuff and they'll turn it into a bright, pretty formula, E equals MC squared, that explains like tons of stuff. And it's great and it's cool and whatever else. Or some statistical model that evidences this thing, whatever else. Right? So don't worry about getting there efficiently. Just worry about getting there. So what you should look at is there anything that I can say that might relate those things together? Yes, ma'am.
What's it called? Could you do the segment addition property?
We almost certainly going to, so we're probably going to use the segment addition property because we're in that lesson. So where could we do segment addition here? What two segments make up a bigger segment? YZ and what other one? XY, sure. Let's do that. So this one plus this one equals that one. That sounds great. Well, I like what you actually said better, so good job. Because the problem with using WZ straight up, so I'm glad you said both things. So we can't do much with that because it's got 3 segments in it, right? So we could do like this one plus this one, but that's less balanced. So I think let's start with what you said to begin with. Let's do this one plus this one equals that one. So let's do that. All right? So the measure of xy x, y equals the measure, no, what am I doing? Sorry. Plus the measure of yz equals the measure of xz. And that sounds particularly useful. That one sounds much more useful. What do we notice about this line when we compare it to looking up here at this line? When we're looking at both of these lines, what do we see? That we like? Yeah, so there's YZs, right? They match, so we could potentially use substitution. Yeah, so we've got something that matches. So let's do another segment addition. Where's another segment addition that might be useful, that has another one of our givens in it? Yeah, WX plus equals WY. That sounds really great. Let's do that. Oh, we need to put Y. We can do this. This is segment addition. And since we're using the same property to get this other line, and we don't have to, and it's not building, we can even just add this on the same line, right? So the measure of WX plus the measure of XY equals the measure of WY. It's the same thing, same line, right? So we don't need anything else. That's sounding really great. So there's a couple different directions we can go next. We've already kind of hinted at one of the directions. There's something else that we're going to need. So what do we want to do next? You also notice, you might notice, if you look here and here, we're trying to prove those. So if we could turn these sides into like the same thing, that would be helpful. Yes, ma'am.
Can we use the symmetric property to switch those around?
To flip these around, oh, to flip which?
The bottom one, WX plus measure XY.
So like put the WX here and the XY here. That's actually the commutative property. But yes, we could do that. That is a thing that we could do. And that is totally fine. Let's do it. So you're wanting this one? Yeah, okay, so 4 measure of X, excuse me, Y plus the measure of WX equals the measure of WY, which is the commutative property. Remember, commute means to move. That one we learned in Algebra 1. And it's also, if you want to look at the book and look at that thing, it also reminds you of it in that algebra proof lesson, if you want to look at it. But you actually learned that one way back in Algebra 1, at the beginning of the year. We just talked about it in my Algebra 1 class. Actually, in fact, if you happen to have taken my pre-algebra class, you might have learned it back then. Okay, so now we've got this in the same order as that and whatever else. That sounds great. What else might we do? We might do a substitution. That sounds really great. What are we going to substitute where? WX. What about it? Okay.
You just do it.
So what we're trying to do, so substitution is the kind of the property that's not hard, but it's kind of tricky to think about what's going on. So you want to look for lines like this, where this equals that often, right? And we want to find places where it matches. So like we've got YZ right here, right? We've also got WX right here and right here, although I'm going to put it on just this one because we switched it around. So we've got WX right there and right there. So we could do some sort of substitution with one or both of those. right?
Why did we switch it around?
So that the XY was in the same order. That is a step that is I don't even know if the book has that step in there. I don't remember. Let's see. Yeah. So the book doesn't actually use that. Actually, the book goes a different direction than I think we're going to ultimately go because they use reflexive property in the middle. I don't know why they do it that way, but they do. And I don't think we're going to need it ultimately. But that is a step that is technically correct and technically necessary because it has to be exactly the same in a minute when we do another substitution in a minute. That is a step that if you left it out on a test or something, I would give you full credit for the thing. But all right, back to substitution. Great question. So we can substitute something with the colors, right? Something that makes it match. And remember our goal is we want this to be congruent to this, right? WY and XZ. We want this to equal this. So if we could get this side to be the same as that side, right? We could do a substitution. So if we could make this match that, then we'd be home free, right? So how could we make turn one of these into the other one?
You substitute the measure of WX for the measure of YZ.
Yeah, so put the measure of WX right here, right? Is that what you're saying? Instead of the YZ. So since YZ equals this, that measure equals that, we can substitute this one in there. That sounds like a great idea. Let's do it. So we're substituting WX right here. So the measure of XY plus the measure of WX equals the measure of XZ. Substitution property. It's going to be okay. You got this. Make sure you're writing things down and using your brain. Don't forget your brain. Don't leave that one at home. It's very important. It's your most important tool. Okay. So now, this and that are the same thing, right? It is crazy, so crazy. So now what could we do? We're almost there. We got 2 more lines of code, proof, and then we're through. MY. You're trying, which is good. I love. The most funnest thing about teaching proofs at the beginning of the year is all of the word salad that happens. People just start throwing out math words and hoping for the best. It's great. I love it. So much fun. I promise you'll be able to at least sort of write a proof by the end of this year if you strap your brain on. Sometimes people forget that. Yes, sir.
You can substitute the measure of XY plus the measure of WX for the measure of WY.
Yeah, so we can take this and stick it here because these two are the same, right? That's probably true. That's probably true. So we can say that the measure of WY equals the measure of XZ which is technically the transitive property, but I'd probably accept it either way. This doesn't quite look like that yet. There's one thing wrong with it. Yeah, we got to turn the measures back into congruent, which we can do straight away. What's the justification for that? Yes. is congruent to XZ because of the definition of congruent segments. Look at that, we did it. You wrote your first proof. Only slightly assisted. Good job. Go team. Yeah, it totally makes sense. The like terrified squealing disregard that. don't look at the man behind the curtain.
There's a man behind the curtain.
So they in the what they did in the book is they used the fact that XY is congruent to XY and then did it that way. And they did like some addition stuff and some other. I like what we did better. I think it makes more sense than what they did. Although what they did totally works as well. And we will use reflexive property a lot. Reflexive property is kind of the most no-duh property of all of them. It's the most no-duh postulate of all the no-duh postulates. A equals A. Really? It does, in fact. I know, it's astonishing. All right, so let's kind of, we're going to kind of do 2.7, the rest of 2.7, the homework bits. We'll kind of talk through some other problems, I think. We'll talk through number 4 together. I may take a picture of number 4 in somebody else's book so it's not filled in and put it up on the screen. So it's going to be easier to do.
That's illegal. I'm just kidding.
It's not actually.
It's probably not.
Although, well, I don't know. That's debatable slightly. Are we on private property or are we on public property? I would argue we're on private property, so probably it is kind of illegal, but then I don't know. Kind of, it would be a slightly gray area. Because like I could go stand on the sidewalk out there, and if I had a zoom lens and could see your face, that would be legal. Because I'm filming you from public space.
But if I'm
It would be creepy, but it would be legal.
so
Right?
You're,
Right?
You're basically saying that if you stood at my house and my window.
If I was standing at the street and your window was open and I filmed you, that would be legal. It would be creepy, but it would be legal. Yeah, if you can see somebody if you can be seen from public space, you can be filmed. There is no presumed right to privacy. That is absolutely false. If a cop has somebody pulled over and they can see the drugs from outside the car, they have not done an illegal search. If they open the car, go through the thing, then they violated their Fourth Amendment rights, unless there's probable cause, and that's a really sticky area, and I would be careful about like arguing with the cop. I would wait and argue with the judge later. But, you know.
The crazy thing is that in Germany, you have the presumed right to privacy in public, and photographers have to go through so much work to get pictures of crowds. In some cases, having to like try and identify everyone in the picture and get their consent on like a
Craziness.
document, and it's crazy.
Yeah. In the U.S., there is no presumed right to privacy. It does not exist in public space. You do have Fourth Amendment, which is very important. Very, very important. I don't think you actually do. I think.
Actually, I don't, because if somebody was like harassing
Private
me,
property rights exist, right? Yeah, exactly. Yeah, no, it's actually a healthy thing.
like if someone was screaming and yelling at me and being a Karen, then I would want to film them.
Be able to film them.
Yeah,
Yeah.
so I
Right.
take it back.
That's the thing. You have to think about like, is the fact that I don't want this to happen to me like more worth my ability to sue someone else?
That is the heart of that side of judicial laws. Absolutely, is balancing freedom versus protection. That's always where is the line? All right, so let's do this one together. What would go here? That one's easy. What would be right here? AE is congruent to BD and probably also these things, right? All of the given bits. Unless that's the other bits. No, yeah. That would be all the given, right? Would be listed right there. So what lets them say that the measure of AC equals the measure of CE and the measure of BC equals the measure of CD? What lets them say these things? That's a good one. Yeah, definition of midpoint. That's exactly right. Midpoint property. Yes, 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 because that's what midpoint says. Midpoint, if it's the midpoint, then the other two segments are equal, yeah? Their measures are equal. So what about AE? The measure of AE equals the measure of BD. Well, let's just say that one. Definition of congruent segments on that one, because they're using this line, right? So, and turning it into their measures being. I know it's a little bit confusing because they don't put the little M. I don't like it when books do that, but you know, this is a pretty good book other than that. They're in this series of books that I use. This is one of the better ones. The worst are the pre-algebra and pre-calculus. I don't know why that is, but it's true. The pre-algebra is well, the pre-calculus isn't bad. There's just several mistakes in the key, which is annoying. Other than that, it's a great book.
What's bad about the pre-algebra one?
It's the order is weird and like well, this is probably just my beef with like the way pre-algebra is taught in general. Like certain units, it's like, no, let's not teach this 5 different ways. Let's teach it the one way that actually makes sense to most people. This is a way better plan, but that's just kind of like how I deal with pre-algebra in general. What is this gonna be? What did you say? Did you say your mom? It's definitely not gonna be your mom. That doesn't make any sense. She's not a segment at all. She is my mother. She has lots of segments, most of them curved, because that's how people work. They're not straight. Pun not intended. Anyway, what segments are going to be added here to do a thing? What is going to be happening here? And I'll give you a hint, unless I'm greatly mistaken. Let me look at the key and see if it agrees with me. But I think there's going to be 2 lines there. Yep, I was exactly right. All right, there's actually 2 lines of there's actually 2 different statements in D. We can do 2 different things because of the segment addition postulate. What is one of them? Okay, so it's the one with AE. Whoa, no, I don't want to talk or share anything. Thank you. Measure of AE is going to be on one side of one of them. What's going to be on the other side? AC, the measure of AC plus the measure of CE equals the measure of AE. Absolutely. That is absolutely going to be one of them right there. What is the other one going to be?
DC plus CB equals DB.
Yeah, they're measures. That's exactly right. Okay, that's great. So that's what's going to be there. The measure of DC plus the measure of CB equals the measure of DB. Great. Except we'd probably do it the other way around so that it matched this. So probably the measure of BC plus the measure of CD equals BD, but only because this is in the order BD, right? Like that kind of thing generally, unless it like matters, is the kind of thing that if you, on a test, if you didn't have that order completely perfect, like if you were going D to B instead of B to D, I would probably give you all the points on a test. I do now. See, here's the thing, and I think it's probably just because it's hard and it's tricky and it's a new part. It's a part of your brain that you haven't probably stretched very much in all your life yet, and so it's good we're doing it. But so it's probably just because of that. But people miss proofs on tests anyway. But I do grade them loosely. I mean, I'm not going to give you credit for like hogwash that's just way off in left field. But if it's basically right, or if you get the words like, I can tell that you meant segment addition postulate and you wrote something that wasn't quite right, but I can tell that's what you meant, then I'll give you credit for it. I'm not like trying to beat you over the head with proofs, but you do have to, learn how to do them. On E, how did they do that?
How do they get it plus?
AC plus CE, so that's part of that, right? Equals the measure of BC plus the measure of CD. So what did they do? Let me zoom out my camera so I can get this whiteboard in there, and then I'll use this whiteboard to write things. Make our life easier. I can write on that screen. I've done it before, but I don't like, oh, I could already have seen the thing. We'll just move the thing slightly down. Don't worry, Natalie. I can only barely see your head. It's okay. Don't stress.
No, you should definitely be stressing.
You always have. That's maybe true. I don't know. All right. So, line E. So what we just said on this line was that the measure of AC plus the measure of CE equals the measure of AE. And we also said the measure of BC plus the measure of CD equals a measure of BD. Great, grand, glorious. How are we doing on our time, by the way? We're done, but we'll finish this one little statement because it'll get us here and there, and then we'll be through. And then we'll be through for the day. So up here, we said that these were all equal, right? And we said that AE equals BD. So this equals this. So this next line is just this equals that, right? This one equals that one. So what property let us do that? Substitution. That's exactly right. All right, they just substituted this for this. Actually, this for this, but you get the point. This one's also a substitution, but it's substituting these things. So it's replacing CE with AC, and it's replacing BC with CD because of this line. This is also substitution. And then the last little bit would be like 2AC equals 2CD, right? Just simplified it. And then when you divide the 2 off on both sides, you just have AC equals CD, and then turn it back into congruence. Don't worry, it will make more and more sense the further we go and the more we practice. You have a lesson due on Thursday. It's the same thing but with angles. I shall see you then.